In this new series on Black Tapes, we're taking a step away from true crime to explore another kind of tragedy, one that happens thousands of feet above the ground. Aviation has always fascinated me, not only for its beauty and complexity, but also for how, in rare and tragic moments, small mistakes or malfunctions can lead to enormous consequences. This new documentary series will focus on aviation disasters, examining what really happened, how investigators uncovered the truth, and what was learned to make flying safer for everyone. Calm, respectful, and cinematic, just like every story told here on Black Tapes. Welcome to Black Tapes, Air Disaster Files. On the night of May 31st, 2009, 228 people boarded Air France Flight 447 in Rio de Janeiro. Businessmen, tourists, families returning home. The Airbus A330 that awaited them was one of the most advanced aircraft ever built. Reliable, modern, and equipped with redundant systems designed to handle nearly any emergency. For the crew, it was supposed to be just another transatlantic flight. A calm journey north, over the vast darkness of the Atlantic, to Paris Charles de Gaulle Airport. But within just a few hours, this routine flight would become one of the most perplexing disasters in modern aviation history. The flight departed at 7:29 p.m. local time. Weather reports showed a line of thunderstorms along the equatorial region, nothing unusual for this route. Pilots were used to it, navigating carefully around the towering cumulonimbus clouds that mark the intertropical convergence zone. Above the calm voices in the cockpit, rain hissed against the fuselage as lightning flickered in the distance. Everything seemed under control. Then, somewhere over the Atlantic, communication stopped. No distress signal, no mayday call. Controllers in Dakar and Brazil tried to contact the aircraft. Silence. It simply disappeared from radar coverage, lost in a region of ocean deeper than Mount Everest is tall. In Paris, families waiting at the arrival gate were told the flight was delayed. Hours later, that delay turned into uncertainty, and then into fear. What followed was one of the largest search operations ever conducted. Nations joined forces to scan thousands of square kilometers of ocean. Days later, fragments of wreckage began to appear on the waves. A seat cushion, a piece of fuselage, personal belongings. The confirmation no one wanted came soon after. Air France Flight 447 had crashed into the Atlantic Ocean. But the question remained: why? For months, investigators were left with almost nothing. The black boxes, lying nearly 4,000 meters below the surface, were beyond reach. No clear signs of explosion, no evidence of fire. It seemed as if the plane had simply fallen from the sky. Speculation spread quickly. Was it lightning? Turbulence? A sudden mechanical failure? The truth would remain buried under the waves for nearly 2 years. When the recorders were finally recovered, they revealed a story far more complex than anyone had imagined. A chain of events triggered by frozen sensors, compounded by confusion in the cockpit, and human reactions under unimaginable pressure. The mystery of Flight 447 wasn't about one mistake or one malfunction. It was about how a few moments of uncertainty, at 35,000 feet, can overwhelm even the most skilled professionals. This episode is not just about tragedy. It's about what we learned from it, about the silent lessons that shaped the future of aviation safety, and about how, in the endless sky above the Atlantic, human fragility met the full force of nature. This is the story of Air France Flight 447, the truth behind the Atlantic tragedy.
When Air France Flight 447 disappeared from radar in the early hours of June 1, 2009, the aviation world entered a state of disbelief. A modern Airbus A330, one of the safest and most reliable aircraft ever built, had vanished without a trace somewhere over the mid-Atlantic. No distress call, no warning, only silence. At 2:14 a.m. UTC, the last automated transmission was received through ACARS, a system that relays maintenance data from the aircraft to the airline. Over just 4 minutes, the system sent a cascade of fault messages, failures in the autopilot, the flight control computers, and the air data reference systems. To the engineers who later analyzed those lines of code, it was the first and only clue that something had gone terribly wrong. But at the time, no one on the ground had any idea what those messages truly meant. In Paris, controllers watched the aircraft disappear from radar coverage. Attempts to contact the crew were unsuccessful. Brazilian air traffic control tried as well. No response. At 4:30 a.m., the aircraft was officially declared missing. By the time the sun rose over the Atlantic, the flight that had left Rio just hours earlier was gone. Families gathered at Charles de Gaulle Airport, expecting to see their loved ones walk through the arrivals gate. Instead, they were met by silence, confusion, and finally, heartbreak. The display still showed en route long after the scheduled landing time. Then, one by one, the monitors changed. Delayed, and then unknown. For many, it was the longest morning of their lives. Air France quickly organized press briefings, while the French and Brazilian governments mobilized naval and air search teams. Within hours, an international rescue operation began, involving satellites, surveillance aircraft, and ships from multiple nations. The search zone stretched across thousands of square kilometers, an area larger than many countries. The weather was brutal: tropical storms, high winds, and violent seas. Aircraft crews scanned the ocean from dawn to dusk, but for days there was nothing. Only waves and clouds. On June 6th, 5 days after the disappearance, a Brazilian Air Force reconnaissance plane spotted fragments floating on the water. A seat cushion, a blue piece of fuselage, and a section of the vertical stabilizer, the Air France logo still visible above the waves. There was no longer any doubt. Flight 447 had gone down. The following weeks brought more debris and eventually the recovery of dozens of bodies. But the crucial evidence, the flight recorders, remained missing. The depth of the Atlantic in that region was nearly 4,000 meters, filled with ridges and canyons, making recovery almost impossible. Without those black boxes, investigators had little more than educated guesses. Speculation filled the headlines. Some blamed severe turbulence or lightning. Others suggested a catastrophic structural failure. A few even whispered about terrorism. But none of those theories fit all the known facts. The aircraft had sent system alerts, meaning it was still functioning, at least partially, in its final moments. So what had really happened in those 4 silent minutes? Months turned into years. 3 major search expeditions scoured the ocean floor, each one costing tens of millions of euros. It wasn't until April 2011, nearly 2 years after the crash, that the wreckage was finally located by a French research vessel equipped with advanced sonar. Images taken by remotely operated vehicles showed haunting scenes. The fuselage lying broken across the seabed, still largely intact. And there, half buried in sediment, were the flight data recorder and the cockpit voice recorder, the keys to understanding the mystery of Flight 447. When investigators from BEA, the French Bureau of Enquiry and Analysis, played back the recordings, they discovered a story not of mechanical failure or sabotage, but of confusion, miscommunication, and human vulnerability in the face of technology. At 2:08 a.m. UTC, the aircraft was flying at 35,000 feet through an area of intense tropical storms near the equator. This region, known as the Intertropical Convergence Zone, is notorious among pilots. A vast belt of turbulence, thunderstorms, and unpredictable winds. The crew, Captain Marc Dubois with 2 co-pilots, Pierre-Cédric Bonin and David Robert, had already discussed the weather ahead. They adjusted their course slightly to avoid the worst of the storms. Rain drummed against the fuselage. Lightning illuminated the clouds outside. Still, everything remained calm. At 2:10 a.m., the pitot tubes, small sensors on the aircraft's nose used to measure airspeed, began to ice over. In heavy moisture and freezing temperatures, such icing could block airflow, causing the sensors to give false readings. In a matter of seconds, the flight computers received contradictory data. To prevent potential errors, the autopilot disconnected. A simple chime sounded in the cockpit.
a sound the crew had heard many times before during simulations. But this time, it marked the beginning of a fatal chain of events. Co-pilot Bonin, who was at the controls, suddenly found himself flying manually at 35,000 feet in turbulence, with instruments showing conflicting information. Believing the aircraft was descending too quickly, he pulled the stick back slightly to gain altitude. The nose of the aircraft rose. The plane began to climb. But with the pitot tubes frozen, the airspeed indicators showed dangerously low speeds. The warning system triggered a stall alarm, meaning the aircraft was losing lift. Bonin, convinced it was an error caused by bad data, kept pulling back on the controls. For over 2 minutes, the cockpit descended into confusion. The other co-pilot, Robert, tried to interpret the displays. "We don't have valid indications," he said. The captain, resting at the time, returned to the cockpit as alarms continued to sound. The Airbus had climbed nearly 3,000 feet higher than its intended altitude and was now entering an aerodynamic stall. Outside, invisible in the darkness, the wings were no longer producing enough lift. The aircraft began to fall. The voice recordings capture the chaos. Overlapping voices, warnings, and disbelief. "Alternate law. Stall, stall. What's happening?" Phrases repeated again and again. None of the pilots seemed to fully grasp that they were stalled. At high altitude, a fully loaded Airbus could not recover easily. Pulling the nose up only made things worse. As the plane descended through 30,000 feet, the stall alarm briefly stopped. Because the sensors were so disrupted, the system no longer recognized the condition. Moments later, the warning returned. They were still falling. The captain tried to take control, but it was too late. For more than 3 minutes, the aircraft fell through the night sky, engines at full thrust, but with the nose still pitched upward. A futile fight against the laws of aerodynamics. At 2:14 a.m., the flight recorder stopped. The aircraft hit the ocean with immense force. All 228 passengers and crew were killed instantly. The debris scattered across the seabed, where it would remain for years. When investigators presented their final report, they concluded that no single cause had brought down Flight 447. It was a chain of small events: the freezing of the pitot tubes, the loss of autopilot, the crew's misunderstanding of their situation, and the failure to recognize the stall. But the deeper cause was human: an over-reliance on automation, and a generation of pilots trained to trust computers more than their own senses. The tragedy reshaped aviation. Airbus modified the pitot sensors to better resist icing. Airlines around the world changed their training programs, placing new emphasis on manual flight skills and high-altitude stall recovery. The disaster also spurred changes to how aircraft are tracked over oceans, ensuring that no plane can ever simply disappear again. For the families, the answers came too late. But for aviation, the legacy of Flight 447 endures. It stands as a haunting reminder that even in an age of advanced technology, the sky remains a place where precision, discipline, and human judgment must coexist, and where a few moments of confusion can still turn a routine flight into tragedy. When the black boxes from Air France Flight 447 were finally brought to the surface in May 2011, they were treated with the same reverence as a time capsule, a fragile link to the final moments of 228 lives lost over the Atlantic. For 2 years, investigators had been forced to work in the dark. Now, at last, they had a voice, the chance to understand what really happened that night. The recorders were transported under heavy security to the BEA laboratory near Paris. Engineers worked for hours, carefully drying and disassembling the units. When the first data appeared on their screens, the room fell silent. For the first time since the disappearance, the investigation had evidence, not fragments or speculation, but the truth, written in numbers and sound. The audio from the cockpit was devastating, not because of panic or chaos, but because of the calm professionalism that persisted until the very end. The voices of the pilots revealed confusion, disbelief, and a desperate struggle to make sense of a situation no one had trained them for. When the stall warning sounded for the first time, it wasn't clear to them that it was real. The frozen pitot tubes had fed false airspeed readings to the instruments, making the alarms appear inconsistent and unreliable. In a moment of crisis, the pilots were forced to decide which warnings to trust, and chose wrong. BEA investigators replayed those final minutes again and again. They built digital models of the aircraft's behavior, recreated the weather conditions, and interviewed Airbus engineers and Air France instructors. The more they looked, the clearer the chain of events became. The autopilot disconnected due to the loss of speed data. The aircraft switched to a less automated alternate law mode, and the pilots, confronted with multiple alarms, reacted instinctively instead of methodically. They had pulled the aircraft into a steep climb, losing speed until it stalled. From that point, recovery was almost impossible. Yet the report went beyond technical errors. It spoke of a deeper issue, one that extended far beyond a single flight. Automation had made commercial aviation safer than ever before, but it had also changed the way pilots interacted with their aircraft. In the rare moments when computers failed, pilots often struggled to understand the raw behavior of the plane. Many of them had never experienced high-altitude stall recovery in real flight, only in theory. The BEA's findings were not meant to assign blame. Instead, they painted a picture of how modern aviation had evolved, where machines could outperform humans, but humans were still expected to understand the machines. In the final report, published in 2012, the agency concluded that the accident resulted from a combination of technical malfunction, inadequate training, and human factors under extreme stress. The report also criticized the lack of guidance for crews facing unreliable airspeed situations, and called for better pilot training, focusing on manual flying and upset recovery at high altitudes. Air France and Airbus both accepted the findings. Within months, airlines around the world revised their procedures, introduced new simulators, and redefined how pilots were taught to handle sudden automation failures. For the families, the release of the final report brought a mix of closure and pain. Some felt relief that the mystery had finally been solved. Others saw only confirmation of what they had long suspected, that their loved ones were victims of a system that trusted machines too much and people too little. At memorial ceremonies in Paris and Rio de Janeiro, their names were read aloud, one by one. In that moment, the investigation became more than a technical exercise. It was a human story, a reminder that behind every data point there was a life, a voice, and a silence that would never be broken. The story of Air France Flight 447 did not end with the recovery of the black boxes or the release of the final report. Its legacy continued to shape aviation for years to come. What investigators, pilots, and engineers learned from that tragedy would quietly transform the way the world flies. One policy, one training program, one sensor at a time. In the months following the report, Airbus redesigned the pitot tubes used on its A330 and A340 fleets. The new models were resistant to icing and tested under extreme conditions. Air France modified its training programs, introducing mandatory sessions focused on high-altitude stall recovery and manual flying. Where once automation was treated as an unshakable safety net, it was now recognized as something that required human understanding, not blind trust. Across the aviation industry, regulators took note. The European Aviation Safety Agency and the FAA revised their guidance on unreliable airspeed scenarios. Simulators were updated to replicate rare but critical failures, the kind that once seemed too improbable to matter. Pilots were encouraged to practice flying by feel again, to rely on attitude indicators and instinct rather than purely on numbers. In classrooms and training centers, Flight 447 became a case study in situational awareness, crew communication, and the limits of technology. The disaster also led to improvements in how aircraft are tracked over the oceans. In 2009, long stretches of transoceanic routes had no radar coverage, leaving planes effectively invisible for hours at a time. That changed. Airlines adopted systems that send position reports every minute via satellite. Search and rescue coordination was redefined so that no future aircraft could ever vanish into the darkness without trace for years, as Flight 447 had. For many in the industry, the tragedy represented a turning point, a reminder that safety is not just a product of technology, but of culture. Pilots began to speak more openly about the challenges of automation dependency. Airlines re-examined their hierarchies and communication protocols within the cockpit, encouraging collaboration rather than deference. A new philosophy took root, that even in the most advanced aircraft, humans remain the final safeguard. For the families, the changes came too late. But their persistence, their demand for truth, ensured that the lessons of Flight 447 would not be forgotten. Each improvement in design and training stands as a quiet tribute to those who lost their lives that night. At memorials in France and Brazil, their names are etched in stone. Reminders not only of tragedy, but of progress born from pain. More than a decade later, commercial aviation is safer than ever. But the legacy of Air France 447 endures, not as a warning of fear, but as a testament to humility. It reminds us that in the complex relationship between man and machine, trust must always be paired with understanding, and that every takeoff, every flight across the sky, is still an act of faith in both technology and the people behind it. This was the legacy of Air France Flight 447, a tragedy that reshaped the skies and taught the world that even the smallest error in the vast silence above the Atlantic can echo forever. This story was more than an investigation. It was a reminder of how fragile perfection can be. Behind every number, every cockpit recording, there were 228 lives, people who trusted the sky and never returned home. At Black Tapes, I want to honor them, not through fear or spectacle, but through remembrance, by telling their story with respect and by recognizing the lessons that came from their loss. Every flight we take today, every moment of safety in the air, is built upon the experiences of those who came before. The passengers and crew of Air France Flight 447 are part of that legacy, and their story reminds us that progress in aviation is written not only in technology, but in humanity. Thank you for watching. This was Black Tapes, and this was the story of Air France Flight 447.